This video is part of a series developed to help you better understand critical health hazards in construction and related industries. Today, we'll focus on diesel particulate matter, or DPM. It's a harmful contaminant produced by diesel engines that are common across building sites. DPM is made up of tiny particles created when diesel fuel doesn't burn completely inside an engine. Because the combustion is not 100% efficient, a mixture of very fine carbon particles forms, along with small amounts of other substances from the fuel and engine processes. These particles are so small that we can't see them with the naked eye. When breathed in, they can reach deep into the lungs where the body finds it difficult to remove them. Over time, this buildup can affect how well we breathe and how healthy our lungs remain. DPM is not just one substance. It's a whole mix of different chemicals that form when diesel fuel burns. The main part is a very fine elemental carbon, which acts like a sponge, carrying other compounds on its surface. Attached to this carbon core can be a range of substances, including polycyclic aromatic hydrocarbons, or PAHs. These are chemicals that form when diesel doesn't burn completely. Some PAHs are known to have serious health impacts. Sulfates and other sulfur compounds. The amount of these depends directly on the sulfur content of the fuel, with lower sulfur fuel producing fewer of the compounds. Trace metals, elements like iron, nickel, and others, can appear in small amounts in DPM, either from the fuel itself or from engine wear and tear. And finally, unburnt organic compounds. Oils and hydrocarbons which don't combust fully can stick to the carbon particles, adding to the chemical mix. The exact mixture depends on the quality of the diesel fuel and how efficiently the engine is running. Cleaner, low-sulfur fuel and well-maintained engines will usually produce less harmful particles, while poor-quality fuel or older engines tend to generate more toxic mixtures. When we breathe in DPM, the particles are so small that our body's natural defences can't filter them out. Normally, the nose and airways catch larger dust and dirt, but DPM is tiny enough to slip deep into the lungs and even pass into the bloodstream. Once inside, these particles don't just disappear. They can build up in lung tissue, causing irritation and inflammation. Over time, this weakens how well the lungs work and makes breathing harder. Because the particles can also carry toxic chemicals and metals, the damage goes beyond the lungs. They can affect the heart and other organs too. Short-term exposure may cause irritated eyes, nose and throat, coughing, headaches and dizziness, but the real concern is long-term exposure, which increases the risk of lung cancer, heart disease and strokes, chronic lung disease, and reduced overall lung function and capacity. This is why the International Agency for Research on Cancer, IARC, has classified DPM as a Group 1 carcinogen, the same category as asbestos and tobacco smoke. On construction sites, DPM exposure isn't just from trucks or cars, it can come from any equipment or tool that burns diesel fuel. Whenever these engines are running, especially in enclosed or poorly ventilated spaces, diesel exhaust builds up quickly. Common sources include heavy machinery like excavators, bulldozers and forklifts, site vehicles such as diesel trucks and utes, and smaller equipment powered by diesel, including generators, compressors, and pumps. While tunnels or workshops aren't sources themselves, working in these confined areas with limited airflow can significantly increase the concentration of diesel exhaust, making them contributing factors to exposure. Just like with other lung hazards, smoking makes things worse. Workers who smoke or vape and who are also exposed to DPM face a much higher risk of lung cancer and heart disease. DPM is a serious but controllable hazard. Understanding what it is, where it's found, and how it harms the body is the first step in managing risk. In our next video, we'll explore how DPM can be controlled through the hierarchy of controls, the current legislation, and how exposure is monitored.